today about an ODE in the simplest form, which is y prime equals f of x. And I'll be using a method which is antiderivative method that we are experienced with. And I'll give you example. Start with number one, y prime equals ex. Y prime equals ex. We ask ourselves, what's the function whose derivative is ex? And it's very obvious. So you can say y equal to ex. And of course, when you integrate, you got to add a constant, and that will be your answer. Another example, let's say you have y prime equals to, xy prime equals to 1 over x. And let's put some conditions next to it. There's a y prime here. Y of e equals to 2, and y prime of e equals 1. And if you look at the conditions over here, the x is very close to the e. So we assume that x greater than 0, not equal to 0. So what you do is just simply take xy prime equals 1 over x. Now we gotta take antiderivative. So when you do the antiderivative, means integrate. So integrate xy prime is equal, and integral 1 over x, ln x plus a constant c. I don't have to put absolute value here because I already said x is positive. So therefore, you can say y prime equal to ln x, or you can leave it like this so they can apply the condition ln x or ln x over x plus c over x, or you can leave it like xy prime. So over here, y of e equals to 2, y prime of e equals 1. This means x is e, y is 1. So x is equal to, you say that y prime is equal to xy prime equal to ln x plus c. And as I said, y prime of e equals 1. This implies replace x by e, y prime by 1. So e equal to ln e plus c. And this means e is equal to c. Let's make c as c1 because I have a couple constants I got to work on. So c1, and this means c1 is equal to e. Therefore, you have y prime equal to ln x over x plus c over x, which is e over x. That's part of the solution. Now, I have to redo it one more time because I do have y prime. Now, I got to reintegrate antiderivative. This implies y equal to ln x integral over x plus integral dx plus integral e over x dx. Now, integral ln x over x, if I put this on the side, integral ln x over x dx, if you say let u equal to ln x, so this means du equal to dx over x, which means they have integral u du, it becomes u squared over 2 plus a constant. With this constant will be absorbed by the other constant. So this means you have y, if I put this, y is equal to ln x squared over 2 plus integral e over x, which comes out to be e ln x, plus another constant, which is c2. So we have, so now I can apply the other condition. Y of e equals to 2. This implies 2 is equal, ln e is 1 over 2, and if I do this, plus e ln x, which comes out to be e ln e, that's just simply e plus a c, and this gives us c to be 2 minus half, which is 2 minus half minus e, and this will give us 4 minus 1, 3 over 2 minus e. Therefore, the final solution will be y equals ln x over 2 squared plus e ln x plus 3 over 2 minus e, which is over here. Now, one more example, which is y prime equal to e x squared and y of 2 equals 1. I do have another initial like IVP, and if you notice here, I have y prime equals ex squared. This ex squared cannot be expressed and using elementary functions. So ex squared can. So if I take antiderivative, y is equal, and the initial value is 2, so I gotta start from 2. So I gotta go from 2 to x e t squared dt plus constant, where t is a dummy variable. Okay, now what happens is this: when I do this application for the initial value, I have y of 2 equals 1. This implies 1 equals integral from 2 to 2 is 0 plus c, which give us c equals 1. Therefore, the answer, the solution to this problem, y is equal to integral from 2 to x et squared dt plus 1. Thank you. Have a good day.